idea of flowchart in them. Why? Because what exactly is a flowchart? Now, a flowchart can be defined in the following way, right? A flowchart is a graphical representation of algorithm. And now the next question is, what is algorithm?
Algorithm is algorithm. It's a specific pattern and use to solve something.
Pattern. Not the right word, but solving problem, I like that, yes.
It's instructions to solve a problem.
Instructions, very good, more accurate, right? Yeah. So, instructions to solve a problem, to be more accurate, it's not just an instruction, it's a step-by-step instruction. So when we are looking at a mathematical problem and we want to solve it in a very systematical way, we usually need an algorithm. And you actually apply algorithm all the time. Just as sometimes you just memorize, gut feeling, solve the maths problem without really thinking through what are the steps that you go through. So to strengthen this aspect of the maths education, okay, the teachers here, we are trying to see if we can incorporate the idea of flowchart to help you to actually learn this better, right? So this is the first one that I'm trying out with you, okay? So let me introduce this flowchart. Now, whoops. Okay, let me redo the FA again. Right. So, in the previous lesson, I actually asked you, right, whether you are familiar with this, right? So, most of you heard of it before, except for a few. So, I just take this opportunity to run through this flowchart. Even if you already know the algorithm, we are going to use this as an introduction to flowchart. Because going forward, okay, we will see a few more flowcharts throughout the syllabus for the rest of the year. Okay. So the flowchart, first thing, right? We use this round stuff to say start and stop. This is how we know, start and end. Okay. So this is the sieve. Now, prime numbers, they go on forever. So it doesn't make sense to say, okay, I want a list of all the prime numbers. Okay, doesn't make sense. But rather, we need to have a cap somewhere. So in the example in your notes, we say, okay, let's stop at 100. Okay. So you do that. But for the purpose of our demonstration, maybe we will just do up to 50. But maybe I will invite you to help me once in a while tap the screen so that it doesn't go into sleep mode. Okay, yeah. So to see how it works, first let's list out the numbers. 1, 2, 3, 4, 5, 6. Okay, running out of space. Okay, never mind. 7. Now, we will make things interesting. We go 8 here, okay? See if it works. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Why not? Find all the prime numbers up to 21, okay? The idea is we just want to see if the logic works, the algorithm works, okay? So, the first step here, get num. Now, num here is basically the short for number. What kind of number is this? I actually define it. The number we want here is actually the maximum we want. So in this case, the num here is 21. Okay, so we want to find the prime number up to 21. Then, how this thing works is that we're going to create a Boolean list. A Boolean list means either true or false, right? That's what Boolean means. So, we are going to begin by assuming that they are all prime. So all true. Then we will eliminate those that's not prime later. So I assume they are all true, right? And then I initialize P to be 2. So I have a P here. Now P basically stands for the current prime number that we are looking at and investigating, right? So we will look at that. So let's begin the algorithm. First question we want to ask is that is the next multiple of P greater than num? What does it mean? So my P is 2, right? Then the next multiple of P will be 4, 6, 8, 10, and so on. So we'll keep testing them until it goes more than 21, right? Because 21 is the num. So it's the next one. Now it's at 2, not yet, right? No, 2, not yet. So if it's not yet, we go down, no. Is P marked as true? Now we're going to start by everything true, right? So it's 5 is true, yes. Okay. Mark all multiples of P as false. So that's the next step. So all multiples of P. So my P was 2. I mark all the multiple false. False. So when I false, I just cancel it out. False. Okay, you keep going. Keep going, keep going, keep going. And done. No more, right? So we finish this step. We go back. Okay. Now let's increase my P. So my P now becomes 3. And then go back. And ask the next question again. Is it more than 21? Not yet, right? Not yet. So we'll keep going. Is P marked as true? Yes. Okay, it's marked as true. Then we now eliminate all the multiples of 3. So this one already eliminated. Multiples of 3 gone. 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 And then after we reach 21, the next one already more. So no more stop, right? So come back. Okay. Same process. Now we increase P. So my P now becomes 4. It becomes 4 first. But then we come back and then we ask the question. Huh? Is it okay? Is it greater? No. But then it comes here. Is it marked as true? No, 4 is not marked as true. It's already false. Therefore, we skip this step. We go this way. Right? So when it's already cancelled out, we come here. If it's not cancelled out, we go down. Okay? So we go to the next one. 5. Increase P again. Okay, so we're here 5, and then all the multiples of 5, they are already eliminated. All good. So we'll keep going, and then this thing becomes 6, then it becomes 7, right? Becomes 6, then becomes 7, and then all the multiples of 7 are already gone. So we keep going, become 8, 9, 10, 11, and then 13, 17, 19, until eventually my P becomes 22. My P will keep increasing. When P becomes 22, bam, greater already. So you jump out here, and then all the numbers that is marked as true, that means not been cancelled, I'm going to put them in the list, and that will be the list of prime numbers that is less than the num, which is 21. So you can see from here, it has a very simple algorithm to it. So the sieve may seem quite common sense, something quite common sense, but we think through, actually there is a proper step-by-step recipe. Okay? So this